before I let you guys read this while I'm doing it, we're actually talking about a fairly specific topic that, in some sense, at least in the aquatic sciences world, is a fairly new topic in terms of survey design. Surveys were not a common part of aquatic monitoring for a long time. They only have for about the last 30 years or so. That's not true in the other natural resources. Forestry's been doing it for a long time. Agriculture's been doing it since the 50s. Resource Conservation Service, natural resource inventory has been going on since the early 70s. So I think, there's a long history in that side. But if you look at surveys in general, they've been surveying people and population since the 1930s, actually since Percy Name wrote his original paper. And they have a much richer history of the types of things they do with surveys. So integrating surveys for design-based estimation is a topic that they actually dealt with in the past. It's one that is becoming much more common now that more people are doing surveys on the natural research side. So in some sense, we're catching up. The good news is somebody's been there before. So one of the questions that really comes up is why do you even want to integrate studies? And particularly the focus here is really on survey design. And there's really sort of 4 reasons that I can think of. One of them is just simply that you want to build a partnership among organizations. That's one of the reasons that I know on the NARS Natural Aquatic Resource Programs, that's one of the things there that you're trying to do is you've got a national organization, EPA, who's trying to partner with the states and the tribes, actually doing things, and you're trying to end up working those together as best you can. I put up some examples from hopefully some of the topics that you're going to hear in the next 2 days, where I know Scott Miller's been trying to do some things with BLM. I've already mentioned the ones on ours, the National Bat Monitoring Program, trying to integrate different people together. It's tough, by the way. And the one that's, I think, is sort of on the fringe about what we want to talk about is integrating citizen monitoring. Because generally, citizen monitoring isn't how we look at survey-based. Not always, but it can be. The other reasons are more technical reasons. One is sometimes you just want to increase sample sizes for a relevant population. I want to know, I'm doing a national survey, but I want to know more about the state of Rhode Island. And Rhode Island, if you're doing a national survey, is not going to get a lot of samples. So if you want to make statements about Rhode Island, you've got to do something to intensify. So that's why you're designing another study to do that. BLM does the similar thing with their districts and that sort of thing. When doing the Great Lakes, we do a near-shore assessment, and then if you you want to look at the embayments. Well, the embayments are less than 5% of the near-shore region. You're not going to get any sites in the near-shore region for the most part. So if you want to talk about embayments, you've got to do another study to deal with that. The other one that's fairly common is you want to talk about trends. One of the things that we do, for example, is we essentially do synoptic surveys. This one is a coastal survey where we did surveys in 2010, 2015, and 2020, and you want to use those 3 time points to talk about trend. And the question is how do you integrate those together to do that in some way? And it seems fairly straightforward until you actually start going into the details, and then you do it. And the last one is you may want to actually increase coverage. And Scott may want to correct me here, but for the most part, BLM game program is on federal lands. NRI, the Natural Resource Inventory, for the most part, when they actually collect data and information, is on private land. But they collect the same type of information. So if you want to talk about all lands in the U.S., you want to end up integrating the two so you can get the coverage that you want. And we've done similar things on streams in the past. So thinking about it in terms of how to issues that you want to cover is one of the things is when you're talking about integrating studies, are you talking about it when you're trying to do the initial design, or you're trying to talk about it when you're doing in the analysis stage? Sometimes somebody presents you with information, you say, I want to combine these studies. The studies have already been done. I want to combine them. There was one done by Mike Mulvey in the state of Oregon for the Willamette Valley on streams a number of years ago. The other one is the question that comes up is when you're talking about the resource, looking at the target population, do they cover the same target populations? Do they overlap, or are they distinct? You need to know that sort of information. What's the time periods covered by the studies? Are the studies all survey designed, or are they a combination of non-probability and probability survey? They present different issues to you, and likely different sets of assumptions that you have to make. And sort of underneath all of those sorts of things are the sample frames the same that are used for the different studies? In some cases they are. So for some of our studies, we know that the state surveys that we end up doing and the national surveys are all based on the same sample frame. I think that's similar to what Scott does in BLM. You have the same sample frame. It makes life a lot easier, by the way. And if they're not the same, then you've got some other issues that you have to deal with. The other question is what do you know about the survey design? Maybe all you know and all you can get a hold of is you know that the survey design was done and you know what the weights are, and you don't know anything else. You don't know how they stratify it. You don't know anything else. What can you do? Can you make use of that study? So at the design stage, for the most part, it's all about timing and the use of the sample frame. Man, it'd be really great if you could actually get all the surveys designed at exactly the same time. That means getting everybody at the table at the same time. That's a really great idea, and I wish it could happen more often. I'm doing a study in the Great Lakes right at the moment, and we can do a nearshore study design today. And we are doing it today. There's likely to be another study based on embayment. That decision will be made sometime in 2019. Maybe. So you're going to have to end up having two separate designs later on. The good news is they're using the same sample frame. But you got to it'd be much better if you could design them at the same time. The political things in terms of when the organizations are ready to do the study just isn't there. And again, having the common sample frame really helps things out enormously. If you're doing it at the analysis stage, it's all about knowing what the target populations are for each of the surveys and how much knowledge do you have about the design. If you only know the weights, then actually combining them is actually, quite frankly, fairly simple. But you have to make some assumptions. If you know all the details about the design, essentially the process is really one of saying, okay, I know the details of these two different survey designs. I know how they overlap and a bunch of other things about the sample frames and so on. If you know enough to do that, then one of the things you can do is go back and essentially reinterpret both designs as if they were done as a single design and essentially redesign it from scratch. That's really the approach that you can take. It takes a lot of work to go through and do that, but you end up having to, because you have to go through and define all the strata, and all the different categories that you need to use, and get the sample frame with those categories and so on. You have to go through that entire process. But that's really a nice way of doing it if you know all that information. Sometimes you just don't have it. So this is just one that it seems simple, but it's one that comes up time and time again. So we did two national lake surveys, one in 2007, one in 2012. And their target populations are not the same. The target population is the same, except for the back in 2007, it was only interested in lakes greater than 4 hectares. In 2012, they made the decision they were interested in all lakes greater than 1 hectare. That's great, because you get a lot more lakes that are of interest to people. So in this case, you've got one study population 1, you have its target population. Study population 2 is actually sort of the overlap. You don't have anything that doesn't overlap. You need to know that if you want to combine those two things to look at trends. Because you're in that, the only way you can look at trends is say, I'm going to look at trends, populations that are greater than 4 hectares. You can't say anything about trends for the population beyond 4. Sample frame, you've got exactly the same problem. You've got to go through and figure out what's going on with the sample frame. Sorry to keep using the example that I've worked with all the time. Going back to this National Lake Survey, when we ended up doing the survey for 1 to 4 hectares, it included 1 to 4 hectare class, the NHD medium resolution sample frame that the thing that we use as sample frame for lakes actually does a fairly poor job of including lakes that are less than 4 hectares. And you can see that by the way that the distribution number of lakes less than 4 hectares sort of starts dropping off. And it's, wait a minute, that's not reality. So we actually ended up going to a high resolution version, or at least a snapshot that they had available to increase that. So we increased the size of the sample population in order to do the next survey. When you want to integrate the 2 studies, you got to take that into account. And other resources have exactly the same sort of issues. At the design stage, if you design them simultaneously, it's fairly straightforward. If you just do a standard survey design, it's going to be a little more complex if you just have one survey versus 2 or 3 of them being designed at the same time. But it's pretty much straightforward to doing it. Easy for me to say until you have to sit down and do it. But and then when you get done, when you want to do the analysis, it's again fairly straightforward, standard sort of analysis for us. If the studies are designed with the same sample frame but not at the same time, then it's a little bit more complicated unless you want to incorporate existing sites into the second survey. There's some procedures that have been done. In particular, I know that PNAP on their website, I think Don Stevens actually ended up having an algorithm to do that sort of thing with incorporating existing sites. It's not as well documented in general within the survey literature exactly how to go about doing that, and there's mixed messages about how you want to end up doing it. If the studies are designed independently, sample frames likely differ. And it's just going to take more work to get something done. You're going to end up having to figure out what sort of a common sample frame are these lines to choose if you really want to be interested. So it's a little bit difficult. At the analysis stage, if you only know the weights, like I say, it's fairly straightforward. There's actually an analysis of health surveys book by Corn and Bob. They have a section there about combining surveys. And essentially what you do is you just do proportional weighting based on sample size. Sample size for survey 1 divided by the sum of the sample size. That's how you proportionally reduce the weights for that survey. And you do the same for the other survey. It's actually based on some estimates about what's going on with the variances between them. And when you do that, you can do it based on the variances if you go through that calculation, but that has to do with the variances of every indicator that you're using in the survey, and you likely don't want to end up doing that for every indicator on the survey, so you can end up backing off, and that's why it sort of simplifies down to this, this ratio of sample sizes. When you do that, you do have the option of sort of backing off and saying, well, it's just not the ratio of the sample sizes for the entire survey, survey that you're doing. You can actually go through and sort of say, well, I'm going to do it where it's based on states. I'm going to do it so that the sample size in each state, I'm going to weight each state separately as I go through and do the process. You got to make some decisions when you do that and see what's effective. One of the things I actually think that you need to watch out for is be careful of getting too small a sample sizes, because you're going to get some really extreme weights if you do that. And our surveys are, quite frankly, at least the ones that most of the ones that I deal with, our sample sizes, quite frankly, are fairly small in general. I mean, monitoring the environment is not inexpensive. So our sample size is necessarily small. And the same, you can do the same thing over time. If you're going to do, if you know all the details, you reinterpret it as a single survey. You got to define, basically you got to define a new set of essentially a post-stratification, if you want to use that term. And you've got to define that so it works for all the surveys that you're trying to integrate. You can end, if you just do it blindly, you can end up getting way more categories than you can handle. Sample sizes will get too small. You can end up having to collapse. Pay attention to those. You got to check to make sure the entire population is covered when you do that. You got samples available in each one of them, and nothing is left out. So you got to do some checking to do it. It's just a lot of detailed work, quite frankly. But there's nothing really really difficult about it conceptually. The weights then are very simple. You've got a common sample frame. You've got the categories. Hey, it's area, the length, or the number of objects in each one of the categories divided by the sample size. That's the way weights are originally calculated to begin with in a single survey. That's exactly what you do. The thing that does happen to you is typically at some point or another you'll end up having to collapse the category. It just doesn't happen to be. Integrating non-survey studies requires some assumptions. Flat out. You have no choice. You got to make some assumptions. And it's all about concept of what is representative. And you try to pull it down. There's some papers on the analysis side about using found data. There's a paper by, I think it's Jake Olson or something like that. Not Scott Olson. He's involved with it. Olson, and actually there's another one on the soil side of and you can do it, but there's mixed viewpoints on how valid it really is, because it does involve some assumptions. At some point, you got to reach down and you get down to the point and you say, well, I defined this category. I've got a set of sites that come from a non-probability survey. I'm willing to make the assumption that they're like a simple random sample. And there's no way around that assumption. Ending on a really positive note.